All right, in this video, I'm going to derive the kinematic equations in more detail and showing more mathematical steps than I did in class today. Okay, so remember in class that we started with AX is dvx dt. I am going to stop writing the x subscripts just to simplify the notation here. So I'm just going to write A equals dv dt. But this is a one-dimensional problem, so all of these we'll be thinking implicitly about our A sub x's and B sub x's, etc. Okay, so this is the problem we're going to start with, and we said, again, remember that A is a constant, and we wanted to see how we could describe this problem as A is a constant. All right, so we're going to start by integrating both sides of this equation. So we're going to have the integral of A, and we're going to redefine our t to t prime, okay, because we're going to make t one of the ends of our integral, okay. And again, this prime here is not a derivative. It just means here's another variable that I would normally call t, but because I'm already using t, I'm going to call it t prime, okay? So this one should be t naught. So we're going to do this integral from t naught to t, and so that's why we're integrating over dt prime so that we can integrate to t and not have the same variable in our equation twice, okay? And then we're going to do the same thing on the right side of our equation. So we're going to redefine our dvx dt as dv dt. And same thing, integrate from t0 to t, dv dt prime, dt prime. Okay? Okay, so the left side of this equation is just a constant, right? Which means that when we do this integration, we have A times t prime evaluated from t prime equals t0 to t prime equals t, all right? And then on the right side of this equation, we can either do as I did in class today and do a change of variables so that we change our variable over what we're integrating for to dv instead of dt, or we can use the argument that the fundamental theorem of calculus says that this is equal to v of t minus v of t naught, and I'm just going to do it that way this time, okay? All right, so now if I plug in for the two endpoints of my interval on the left side, I get a t minus a t naught. And then on the right side, I'm just going to call v of t just v, and v of t naught we're going to call v naught, okay? And so that leaves us this equation here, which we can rearrange to write as v equals v naught plus a times t minus t naught, okay? We're here. I've moved my v naught to the other side of the equation, and then I have flipped my left and right side of my equations, okay? And then on this here, I have pulled an a out, okay, since that was multiplied by both t and t naught, right? So this here is our first kinematic equation, okay? All right. Then the next one, to get that, we're going to start with the fact that v is dx dt. Again, remember, this v here is really vx, but I'm going to stop writing all the subscripts because it just clutters things up a little bit. And we already found just now that v was equal to v naught plus a times t minus t naught. So I'm going to go ahead and write that here. So I just substituted this equation in here. And now I'm going to redefine t as t prime, just like I did above, and for the same reason, because we're going to integrate, we want to have a new name for it so that when we integrate over it, we can call it t, right? So I'm going to write dx dt prime equals v naught plus a t prime minus t naught. And now I don't change the name of t naught because that's just a constant at this point, right? So I can just leave it be. And then I left myself a little bit of room, so I can go ahead and add the integrals to both sides of my equation. So I'm going to do that here. Okay. And now on the left side, I can do like I did in class and change variables, or I can just use the fundamental theorem of calculus. There's probably an easier way to do this. So we will just say on the left that this is x of t minus x of t naught. And as before, we'll just rename x of t to just be x, and x of t naught we're going to call x naught. All right, so that's my left side of my equation. Okay, on the right side, I want to think about which of these things are just basically constants and which things I actually need to consider as variables. So we will rearrange that equation here to remind ourselves that we've got v naught minus a t naught. That's all just a constant, and then plus a t prime dt prime. Now we can do this integral. So this term here, again, is just a constant. And so when we integrate that, we get v naught minus a t naught t prime evaluated from t prime equals t naught to t. And then this second term here is just a linear function of t prime, and so when we integrate that, we get 1/2 a t prime squared, again evaluated from t prime equals t naught to t. Okay, and now we'll plug in for these ends of the integrals. Move this up to the top here. So on my left side of my equation, I've still got x equals x naught. And then I have v naught minus a t naught times t minus t naught plus 1/2 a t squared minus t naught squared. Okay. And now I'm going to do a bit of rearranging of this equation to make it a little bit nicer to work with. So first, I'm really trying to get an equation from x, so I'm going to move x naught over to the right side of my equation. So I've got x equals x naught plus, now I want to put all my terms with v's together and all my terms with a's together. So we'll start with the v term. So I've got v naught times t minus t naught. Okay. That's this first term. And then now I have this, I'm going to get a different color to highlight this. I've got this a t naught that needs to be multiplied by both t and t naught. And so let's start by putting we're going to put all the terms with a together here. Okay. So I'm going to start actually by pulling out a 1/2 a, and then first, let's gather up all the terms that have a t squared in them, multiplied times a. So that's just this one. So I've got t squared here. And then we want to put together all the terms that have a t naught times t, which is just this one here, this a t naught times t. All right. And because I've folded out this factor of 1/2 inside this parentheses here, that's going to be a... sorry, I'm having trouble with my pen, minus 2 t naught t, okay? And then now finally I have my t naught squared terms, okay? Now again, I've got this one here, this t naught times this a t naught, and there's a negative times a negative here, so that's going to be a positive. And again, I've pulled out a 1/2 here, and so I'm going to have that, it's going to have a factor of 2 inside my parentheses, so I've got 2 t naught squared, right? And then I finally got this last t naught squared term, which I've got already like that, okay? And so now this whole thing, right, is t squared minus 2 t naught t plus t naught squared, which is t minus t naught squared. whole thing isn't equal to that, but just the, it's highlighted in a different color, just this part there is equal to this, okay? And so now when I rearrange it that way, I get x equals x naught plus v naught t minus t naught plus 1/2 a t minus t naught squared, right? And that is our second kinematic equation, all right? And then finally, we would like to write a kinematic equation that gets rid of our t's, because there'll be times when we don't have t or we don't want to find t. Okay, and so to do that, we are going to substitute into this last equation to get rid of our t minus t naught. And so you see that every time there's a t minus t naught. Okay, so we want something in terms of t minus t naught that we can substitute for it. And if we go back to our first kinematic equation, that one was Vx. Oh, sorry, I forgot I'm not writing my subscripts. That one was just V, which is really Vx. I'm just not writing all the subscripts, equals V naught plus A t minus t naught. Let's solve that for t minus t naught so we can substitute it in up here. So that gives us me minus V naught over A is t minus t naught. I got there by subtracting V naught for both sides and dividing by A. Right? Okay, and now I'm going to substitute this in to our second equation here. So that will give me x equals x naught plus v naught. Now here's where I'm doing the substitution. So v minus v naught over a plus 1/2 a v minus v naught over a quantity squared. Okay, now we're going to rearrange this one to make it look a little bit nicer. Okay, so I'm going to start by multiplying through, actually I'm going to start by moving x naught over to the other side. So let me just do that here. I'm just going to erase this since it's a video so you can see what happened there. All right, and then now I'm going to multiply through this whole equation by a. So that's going to give me x minus x naught times a. And then now that cancels with this a. And then in the second term, there is this a on the bottom and this a on the top, but this a on the bottom is squared because of this. And so all of these have canceled. One by the one I multiplied through and one by the one that was already there, okay? All right, so I'll have a only on the left side of the equation, not on the right side of the equation. Okay, and then now let's rearrange these other terms to make them look a little bit nicer. So we have v naught v minus v naught squared plus 1/2 v squared minus 2v v naught plus v naught squared. All right, I'm going to do a little bit more rearranging. I'm going to multiply through by 2. So that's going to cancel with that 1/2. That's going to have me multiplying by 2 on that term and by 2 on this term. Okay, and so now I've got 2a x minus x naught equals 2 v naught v minus v naught squared plus v squared minus 2v naught v plus v naught squared. Okay, got 2 of these that cancel with each other. Oops, I forgot to draw I forgot to multiply through by 2 here. So this should have been 2v naught squared. This needs to be multiplied by both. Okay, and so then on the right side of this equation, I am left with v squared minus v naught squared equals 2a x minus x naught. All right, and then I'm just going to rearrange that to have it the way we wrote it in class today, which is v squared equals v naught squared plus 2a x minus x naught, which is our, there we go, which is our third kinematic